Okay, Algebra 1, this is 8.1. We're adding and subtracting polynomials today. So what is a polynomial? A polynomial, guys, is made up of terms. And these terms are called monomials. So we can just say that it's, many terms is what maybe we'll say. It's many terms. And these terms are called monomials. So a monomial is a single term. Now when I say a single term, now we're going to back up even more. So a polynomial is many terms, as in many terms added or subtracted. So maybe we'll put in there added, subtracted. So a single term, guys, can be a single number, a constant, so it could be something like 2. It can be something like x. It can be h. It matters what a polynomial is made up of or a monomial is made up of. But it also can be something like a negative 3x squared. That negative 3x squared is considered a monomial. It's a single term. When everything's multiplied together, grouped together like that, that is a single term. So if I go down to a binomial is 2 terms. And so you get something like x minus 3. You might get something like 2x to the 4th plus x squared. Those are binomials. 2 of them. What do you think a trinomial means? 3 of them. So it's 3 terms. So it's 3 terms. A lot of times we're going to see things like 2x squared minus 4x minus 2. That's a trinomial. It's a quadratic. Degree 2. Now, each one of these things has a degree. The degree, and it doesn't matter if it's a monomial, binomial, trinomial, 4 terms, 5 terms, 8 terms, 20 terms. The degree of a polynomial, guys, is the highest exponent. It's the highest exponent. It's important that you have that it's the highest exponent. What we should do then is talk about standard form. I'm going to add standard form on the bottom here. Standard form of a polynomial is highest to lowest degrees. So when you're looking at the degrees of all of the pieces, and I'll use the trinomial that we have here. This trinomial here is degree 2. Why? Because the highest exponent of all of them is a 2. That's the degree. This is also what I consider to be standard form. Why? Because the one with the highest power exponent is first, which is a 2, and then we go to the x's, which has a little 1 there that's not seen. That's the next highest exponent, and then it goes to the constant. Remember, the constant has a 0 exponent on the variable. So therefore, 2, 1, 0. This is in standard form. If it was out of order, that wouldn't be standard form. So part of your problems is going to be naming it, which is on the next slide. What kind of degree is it? And then, hey, what is the standard form of this problem? So here are the names. We have degree 0, 1, 2, 3, 4, 5, and 6 or more. Notice that 6 or more, we kind of gave up on naming them. It's the 6th degree, 7th degree, and so on. But if it's a 0 degree, which means there's no variable there, it's just a number, it's called constant. First degree is linear, that's a line. Then quadratic, cubic, quartic, and quintic. One more thing I want to add to this is something called leading coefficient. Our leading coefficient, maybe I'm going to squeeze that in here. I'll change colors for you guys so you can see it. Leading coefficient. A leading coefficient, guys, is the number in front of highest exponent. So the one with the highest exponent, sorry it got small there, the leading coefficient is the number, when it's in standard form, that's up front. So let's look back at our problem here of our trinomial. This is in standard form, highest to lowest power, right? We're going to do an example of all these. But 2x squared is the leading term. That means the 2 is the leading coefficient. If I go up here to the x minus 3, what's the leading coefficient? What number is on the x? What's here? Nothing's there. It actually is something there. What is it? It's a 1. So 1 is the leading coefficient there. What about this one? What's the leading coefficient? It's in standard form already, highest to lowest. What's that number? 2. What's the leading coefficient here? It's a monomial. It's just 2. How many coefficients are there? Just 1. The answer is 2. Okay? So let's take this problem. I want you to write this in standard form and then identify the leading coefficient. I'll give you guys a couple seconds on your own. So the first thing we should do then is put it into standard form like it asks us, because if it's in standard form, you look to the front, you got your leading coefficient. What's the highest exponent? It's the 5. So the 5 is associated with the 4x to the 5th. So what we're going to do is write that first. It's a positive 4x to the 5th. The next highest exponent in this problem is the 2, which is a positive 3x squared minus 7x that goes along for the ride. We're not going to do anything with it. Now, I said put it in standard form and then say find me the leading coefficient. And so the leading coefficient is 4. Not 4x to the 5th. Just the constant or the number or coefficient, sorry, that's on front. I also want you guys to tell me the degree of this. When it's in standard form, what's the degree? 5. It's the highest exponent. And going back to our chart, if I wanted to name this, it would be called quintic. So it would be quintic. Okay? That's what you have to do. Now, the next section is adding polynomials. Guys, this is actually a fairly straightforward thing. They make it look more difficult than it really is. Do you guys know how to add like terms? Yeah, we've been doing that now. So, that's all you have to do. Now, the one thing I will say before you add like terms is you need to get rid of the parentheses first. Now, anytime I have a set of parentheses on a group, we need to check what's out front. What's in front of this parentheses? Is there anything there? There actually is something there. It's a 1. And 1 times something is that something. It doesn't change it, does it? So guess what I'm going to do? I'm just going to rewrite it without the parentheses. I know this seems like a lot more work than is needed, but I do like to just rewrite it without the parentheses. I look at the second group. What's out front of this group? A positive 1. And a positive 1 times a group again is itself. So nothing's going to change. Now, what I did there was I made it all one continuous line that I just have to put together. And when I put these together, I am going to put them together in standard form. What does that mean? It means I search for the highest exponent first. Highest exponent is what? 2. How many of those do I have? 2. You have 2 of them. And so this is what I'm going to do. So that I can signify what I have done and what I have not done, I am going to underline the highest exponents. Now you can use whatever you want. If you want to put a box around them, I'm going to change it up every time though. And so now I just have to ask myself, 5x squared minus 3x squared. 5 minus 3 is 2. I'll have 2 of them, and them are x squareds. Now that I did x squareds, the next power from x squared would be x to the first, or x. I look for my x's. I got an x there, and I have an x here. Notice that I use a squiggly line. The squiggly line tells me that I'm going to put those pieces together. I have a negative 3 of them and 6 of them, which leaves me with how many of them? How many will I have then? Negative 3 plus 6. Positive 3 of them. And the last one are my constants. I'll put a curved line under it. What's 4 minus 3? Plus 1. And you're done. So this one is the same as adding, but we're going to subtract in the middle. Here's the cool part about this. The steps that I told you to take care of when adding them together will take care of the negative sign. Because my steps were, get rid of the parentheses first. And again, at least on this particular parentheses, or in the first group here, we still have a 1 out front. So that means this first group is unchanged. Guys, sometimes they'll put a 2 in front of there or an 8 in front of there. You have to distribute that number or whatever it is. But in this case, they don't, and so it becomes 4x cubed minus 3x squared plus 6x minus 4. That's unchanged. But when I get to the second group, what's in front of there? It's a negative 1. So I need to take that negative 1 and distribute it in to every term. Okay, 90% of the time I will never make the rainbows first. I always like to connect 1 and then multiply. But I changed colors to show that I will be distributing to all of the terms. A negative times negative 2x cubed. It's a positive 2x cubed. A negative 1 times a positive x squared makes it a negative x squared. And a negative times negative 2 is 2. And at this point, ladies and gentlemen, it now is the same as it was for addition. Gather related terms. You look for, what's the highest exponent? 3. I have one here, and I have one here. What's 2 of them plus 4 of them plus 2 of them?
6.
So 6 of them, and them were x cubes. Moving on to the x squareds, I have negative 3 and negative 1. Maybe a negative 4x squared. If you borrowed $3 from someone and borrowed another $1, you're negative $4 in the hole. Moving on, we have this term, x's. Oh, that looks like it's the only one, right?
Yeah.
So that means we have 6x. And I'll put a double line underneath this one. Negative 4 plus 2. Oh, negative 2. And there's your answer.